In this lesson, we'll continue our review of Math Test 8, Section 4, Calculator Permitted, questions 20 and 21. Actually, I also do 22 in this video because it's part of a two-part set. All right, let's take a look at 20. The average annual energy cost for a certain home is $4,334. The homeowner plans to spend $25,000 to install a geothermal heating system. The homeowner estimates that the average annual energy cost will then be $2,712. Which of the following inequalities can be solved to find T, the number of years after the installation at which the total amount of energy cost savings will exceed the installation cost? And so we just have to set up an inequality here. We know that at the outset he's spending $25,000. That's extra money to install this system. We want to see at what point do the savings exceed this $25,000. Now typically it's $4,334, but after the install it's only $2,712. So the savings, this is per year, and if you look at the choices, we don't even have to figure this out because they just set it up like this. So this is the savings per year. We want to see how long before the savings, how many years, T is the number of years, exceed the 25,000. And so if you look at the choices here, this one has the savings times T, but we don't want the 25,000 to be greater. We want the savings times T to exceed it. And so this definitely is the choice. Look at the answers to help you out, but it's a pretty common question, just sort of understanding that's the practical application of this inequality, and it's B. All right, let's take a look at question 21. I'm going to do 22 as well. Between 1985 and 2003, data were collected every 3 years on the amount of plastic produced annually in the U.S. in billions of pounds. The graph below shows the data and a line of best fit. The equation of the line of best fit, here's the equation where X is the number of years since 1985 and Y is the amount of plastic produced annually in billions of years. So let's take a look at the graph. On the Y, we've got the amount of plastics in billions of pounds and number of years since 85 on the X. And so at this point here with 0, this is 0 years since 85. It's 1985. And then we're increasing number of years. This would go all the way up to 2005. All right, let's take a look at the first question. Here we have, which of the following is the best interpretation of the number 3.39 in the context of the problem? Let's take a look at 3.39. This is part of the equation, right? Yes. All right, so here's the equation. They're giving us a linear equation, and even though it's set to a real situation, if you understand these linear equations and how they relate, we know that the y-intercept, this would be at 0. At 1985, this was the amount, 46.89. But then we have 3.39 times x. This is the slope, right? Y equals mx plus b. 3.39 is the slope. That's the annual increase. And so let's take a look at the choices. Looks like D, the average annual increase in billions of pounds of plastic produced in the U.S. between the years on the graph. So it's just using that linear equation and applying it to the situation. That's what it means. If they asked for what was the initial amount at 85, that would be the y-intercept, right? That would be the 46.89. All right, let's do the last question. This, again, is a two-part question. 22. Which of the following is the closest to the percent increase in billions of pounds of plastic produced in the U.S. from 2000 to 2003? Now, you want to be careful. This question does appear percent increase or decrease. Let me just give you a little bit of an overview. It could be a graph question like we have here. If you have a percent increase or decrease. So let's say we went from, just random example, we went from 10 to 16, and we want the percent increase. Whatever number you're starting with before the change, we call it the base. Base meaning the initial amount, but also think about base as the bottom of the ratio. It's the denominator. We're always going to put the starting amount. On the top, we are not putting a 16 because we're asked to find percent change, and we're already at 10. We went from 10 to 16. You're going to put a 6. This would give you the percent increase. If we went from 10 and then we went down to, let's say, 3, we'd still put a 10 on the bottom, but we put a 7. That's how much it declined by. You don't need a negative because that's what decrease means. So if you just remember percent increase or decrease, whatever you're starting with on the bottom, so we're looking for 2000, and then the change in 2003. So let's go back to the table. All right, so 2000, we know that's going to be 15 years from 85. That is going to be right here. All right, so we go straight up, and this looks to be exactly 100. That's the starting amount. We're going to put this on the bottom. All right, 2003, that's going to be 18 years after 85. So that's going to be this. We go straight up, and it's this point. And this point looks to be, all right, there's 100. It's a little less than 110. Let's just call it like maybe 108, 109. All right, so we are not putting a 108 on the top. I just want to make this clear. That's the mistake a lot of students put because we're already at 100. The number we put on the top is 8, right? That is going to give the percent increase. So it's an important point. Just keep that in mind. So this is going to be about 8%. And let's take a look at the choices. All right. So we don't see 8%, but you see how it says the closest, and maybe we're off estimating the percent by 1 or 2, but it has to be 10. It's definitely not 44 or 77 or 110. 110 is the mistake I think a lot of students make because they put the 108 on the top. You put the difference. The answer is A.